Hello everyone, welcome to this video where we're going to be looking at how we can use S Foundation's command history tool to actually facilitate the creation of Python scripts without having to write any code ourselves. So it's a great way for perhaps somebody inexperienced with Python and scripting and really automation and so on within the software to gain access to a lot of powerful capabilities. Now to start off, you want to be able to see the command history window. And to do that, you can go to the window menu within S Foundation. And I currently have it off, but you can see it's number 1 in the list here, command history. If I just toggle this on, it's going to appear in the bottom left. And you'll notice here, it's got the name command, and then underneath it, it's going to list the different commands or the different mouse clicks or inputs that I've made to the software since I've started this file. So the first one is I've created a new file, and it's using the US template, which is what I have set as my default for this particular file. And what I want to do next is I want to define a foundation and just keep an eye on the command history as we go. So I'm going to start by creating a spread footing, and I'm just going to stick with the defaults under the isolated footing tool. You'll notice here the dimensions for the pedestals, the pads, and the base plates. We'll just keep this all as default, and I'm just going to place it here at about 8 feet in the y-axis. I'll left click this point, and it's created that foundation. And let me just switch out of the foundation tool now and back to the selection tool. And we can see here under the command list, in the command history, we now have a record, and I'll expand this to the right so we can see it a little bit easier, where it's showing me command number 2 is inserting a joint, which was that point that I clicked at 8 feet in the y-axis. It's also inserted a base plate, a pad, a pedestal, a solo profile, and then the isolated footing is basically what comprises all of those different, or is comprised of all those different components. I can right-click on this command, and I can look at the command details, and I can see all the details that were inserted. So I have the joint, where that joint is located. I have the pad and the dimensions related to that pad and other properties related to that. And let me continue making some adjustments to this model. First of all, I'll add a reaction load. And I can start by creating a new load case, so just using the default one that's going to start off with. So let me just create a new load case here. And I'm going to say, let's call this one test, just to give it a very recognizable name. And I'll click OK. So all I've done so far is I created a test load case, but it doesn't have any loads within it right now. That's actually what, we don't see any reaction loads for a load case. That's why we'll see this red arrow here indicating the absence of any reaction loads. But underneath this load case now, I'm going to add an FZ reaction load, basically in the direction of gravity of 300 kips. And I'll left click at this point here, the joint that I used to insert the foundation, to apply it. And here we can see that reaction load has changed from red, meaning the absence of a reaction load, to this blue color. And I can actually display the label of my FZ magnitude 300 kips. And while I did that, we can see here that it's inserted 2 new commands. So we created our design load case, which we called test. And it says we created a reaction load, although we actually didn't create one, we just left it blank. And we can also see in this example here, in this command, it's inserted the reaction load. If I right click and look at command details, I can see the 300 kip magnitude. So now we've got this model created, we've got a load on it. We could go ahead and run the analysis now, but before I do that, I actually want to right click and look at define pad pile cap. And within this here, let's just say for variety, we're going to change the dimensions. So I'm going to make this 140 inches rather than its original magnitude, or dimension rather, for depth. You can see it's adjusted, and I'll just click OK. The reflecting change has appeared here graphically, and also I see the update pad command. So this is all well and good. This isn't necessarily something that would be difficult to do by hand, but we could have done this with any type of operation we completed within S Foundation through the interface. And then once I'm done, I can right click and I can say, let's export a script, which will create a Python script detailing all the different commands that I've made through the interface and showing us how those can be accessed through the API. I can also export a final state Python script, which basically just allows me to create a Python script that gets me to the final point of what we see here on screen, or a more minimal version of the original Python script. I'm going to go with the default here, the first one in the list, export script. And it's going to ask me to save this, so I'm just going to give it a name. And we can see here it's opened up the script editor window, and I'm just going to expand this and explain what's going on here. So here we can see that we've got a couple different commands that have occurred, and they're all referenced back to this command history window. So I have command number 1 is the new file, where it's using the US template to create the new file. Command number 2 is to insert the joint, the base plate, and so on. It's creating some tolerances as well, which is important for generating the model. But you can see here's the location of joint number 1. We can see the Y location equals 8 feet. X and Z are 0. That's exactly where I drew it. We can also see the dimensions of the base plate, the pad, and detailed rebar information as well. I'll continue scrolling through until I get to command number 3. And in this example, we're creating a load case, and we've named it test. As you can see here, there's a name. But right now, there's no magnitude associated with this particular load. There's no reaction load assigned. It's basically being left out. But in command number 4, this is where we add the reaction load. So we can see here the reaction load of 300 kips. And in command number 5, you may remember we updated the pad with some new dimensions. So I changed the depth from, I believe it was 100 inches to 140 inches. Everything else stayed the same. Now this is helpful because all of these different commands that I went through within the interface have exposed the Python script code and the syntax related to it that I would need to actually write this program to do it myself. So I don't necessarily need to generate it all myself. I can have the interface help me do that. And whenever I perform an operation in the interface and an export to a Python script, it's going to expose that bit of code that was necessary to complete that task. And I can modify it as well. So not only can I modify it, I can also add additional operations like loops and so on that might help me work in a more efficient fashion. For this example here, let me just modify this slightly. So what I'll do is I'll just change this x coordinate from 0 feet to 8 feet. And I'm going to scroll down a little bit further. And I'm also going to change the magnitude of the load from 300 kips to, I'll say, 400 kips, just as an example. And what I'll do next is I'm going to go ahead and run the script. So I'll click Run Script. It's going to ask me if I want to save this. I'm not going to retain the data here, so I'm just going to click No, I don't need to save it. And it went pretty fast there, but if you're paying attention, what it originally did was it placed a foundation, but the insertion point was different than the previous. You may remember previously my insertion point was along the y-axis, 8 feet away from the origin. Now it's kind of at a 45-degree angle from the origin at 8 feet in the x and y-axis. And it's obviously updated the pad, and it's created a foundation reaction load as well. So if I look here, there is definitely a reaction load, and I would just want to look at the magnitude. And we can see that it's negative 400 kips rather than 300, which we had originally specified in the interface, but we had subsequently gone through and actually edited it within the Python script itself. Now I can expose additional details. For example, if I wanted to change the design code, I could go to the design input window, and currently within my Python script, there was nowhere in that script that identified where I could change that design code. Right now it's set to ACI 19. Let's just say, for example, here I wanted to change it to the EC2 code. I could do that here. And maybe I also want to change some of the finite element details. So for example, I might want to change the size of the mesh. I'm going to change this from 2 feet down to, say, 1.5 feet. And maybe for the pedestal here, I'll also reduce that. I'll say from 1 foot to 0.5 feet. And this will obviously change the mesh size in the model. But now you'll notice that I've got these updated isolated footing commands. And if I were to then export this script to Python, I'll give it a new name. Here I can see my new script contains, for the most part, the same data that I had before with the new parameters that I've entered. For example, my x location or my x coordinate for my joint. But when I scroll down to, say, command number 6, which we can see down here, we can see that it's exposing additional details from the code. So for example, here, It's changed the element size for my pad. It's changed the design code that's being used. So this data wasn't previously exposed in the changes that I made. You also notice here it's changed the pedestal element size in command number 7. So it's able to keep track of this, and then if I wanted to make any of these changes programmatically, it's very easy for me to understand where that is. So this information can then be leveraged for future designs without even having to go through the interface. Hopefully you enjoyed this video. If you'd like more information about S Foundation, please check out our YouTube channel. We also have a training course available for anybody that's interested through the Altair 1 learning management system.